Here we go. And there he is, right? Look at that. Looks like we have depth. This is a 2D game, but they were adding some like 3D feeling to it. Welcome back to Arcade. I am Super Tommy, and this is part 2 in creating a memory match game like you've seen in Mario Party for the Nintendo 64. Now do check out part 1 as we set up this character and got him to move, and we explained what the memory match game is. It's like the memory game with cards, except a bit more fun with some more interactive elements. We're going to move a character around and then pick one of 9 boxes to select, and when we select that box, it's going to show us what is inside. So in this part, we're going to set up our boxes. So we have a grid, a 3x3 grid of 9 boxes, and now 8 of those are going to be or 4 of those will be pairs, and 1 will be a whammy, or like a negative thing you pick. If you select it, you will lose some time, or you'll stop being able to move for some amount of time. So now let's add a box, right? So let's just very simply, so we're going to do physics dot add, call it a sprite. Could also just be an image actually. So we're going to put it at, let's say, width times a quarter, and then we're going to be down at 150 from the height, and it's going to use the Sokoban sprite sheet that we have, this guy over here that our character animations are in, but also all the rest of the stuff. Now we're going to use basically these boxes. Or yeah, these boxes. Sokoban is a push box game, so we'll just call these boxes. So this row is 13 items long, so which means this is index 12, 11, 10. So let's use the silver one. So we're going to use frame 10. Let's just see it. And there it is. So this is our box. Now let's actually see, let's just turn on the debug for arcade physics. I like to do that just so that I can see what the hitbox of things look like. So there it is. Okay. Cool. Okay, good. Now these boxes only need to be static. But now that we've seen that, we've shown it, we're going to make a group to make these boxes. We'll be making 9 of them. And it'll just be easier to add collisions with the player if we're using a group. So let's make a group. Up here, we're going to make let's call this box group, a class property. Do refer to part 1 if you're unclear what the class property is. It's a modern JavaScript feature that the Phaser 3 parcel template lets you use by default. It has the libraries you need to install. Phaser.physics.arcade.static group. It's going to be a static group so that it makes static sprites or static bodies. So this dot box group, this dot physics dot add dot static group. Okay, good. We can delete this. Well, let's just say this dot box group dot get. Right, this should be about the same. Is that true? Yep. So nothing should change, other than now we have a blue box around a blue bounding box around our box image here. So that's good. So now we need 8 more of these. So let's make a method here to create boxes. Let's say, why not? So we know it's going to be a 3x3 grid, but let's see. So we know we're going to have to put things into the box. Let's just make this. Let's see, row less than 3 plus row, and then this is column, call less than 3 since it's 3x3, plus call. Okay, and so for each one of these, we're going to do this dot box group dot get. So now the x and y. So let's say so we know y. Y is going to be, just so that they're separated here, about 100 start at 150 and then add 150 each time. So what's going to be a little bit different here is x. We're going to use percentage like we did here, as you can see, width times quarter. So we're going to call this x per 0.25, and then we want the width. So const width, this dot scale dot width. And so what we want here is width times x per, right? So that'll give us the quarter, and then y, and then the same Sokoban frame and the texture in the 10th frame. And then for each column, we're going to x per plus equals 0.25, another quarter percent. And then after the columns have been made, we're going to put x percentage back to 1/4, and then y is going to add 150. And so this dot create boxes should put the boxes on the game screen. Great. Now our dude is actually here, just behind the box. So let's put our dude at 0.6, so 60% down from the top of the screen. So that's better. You see they are colliding. We have not added a collider yet, so nothing's happening. But he is a bit too big. So let's just make our player collision box smaller, since it doesn't need to be this big. And the way the perspective is, you're going to want him to like be able to walk behind, like right here, right? So that looks about right. But the collision box will block you from doing that. So we're going to change the collision box for both items right now, so that we can do that. So we're going to use some depth sorting too. If you do need to know about depth sorting, we do recommend, if you go to the YouTube Arcade channel, Arcade HQ, we have a bunch of algorithms videos, and one of them looks at selection sort. Let's go to playlists here. Algorithms in JavaScript playlist. We have a insertion sort for 2D depth sorting. That's the video you're going to want to check out if you want a description of depth sorting. We're going to do it real quick here. Okay, so let's make our player's collision box here. So we're going to do set size. Here's a rectangle, so set size. So we're going to want, so we know he's 64 by 64. Let's say just 40 on the width, and then let's say 16 on the height. What does that look like? That is small. That may be okay. But now we're going to set the offset. And the offset, so let's see, he's 64 minus 40, that's 14, so maybe 12. And then, so I just did that math by 24 plus 40 is 64. Divide 24 in half is 12, so you get the box basically to this edge. Now 16, 64, right, that had 16, 64. 16 times 4. So we are going to want, let's say 32, right? No, maybe, I don't know. Math. Let's see what that looks like. It's not, so maybe it's 48. Yeah. And so let's see, let's just get this box basically below, no, 2 below, not 48. 36, right? Okay. We can keep adjusting these numbers, but that's probably not bad. I just tried 38. Yeah, that's better. Okay, so now we have this much smaller hitbox. So then when our character is here, let's say, and it's colliding with the front of the box, it will be over it so that it looks like there's like a depth for these items. So now for each box, we do the same thing. Dot set size, and the box is probably 64, right? I think so. There's no padding or anything, so the width will be 64. And then let's just say it's 32 height, and then set offset. So there's no IntelliSense here because it's giving us a any. We know it's not an any, so let's do this. This is how I usually like to do it so that I can get type information. We know we're getting a physics sprite. So phaser.physics.arcade.sprite, and then we can do, box. Dot set offset, so no offset on the x, and then 32 offset on the Y. Let's see what happens. Okay, now they're about half. So maybe that's too much, right? If you can walk over here, does that look right? That may look okay. Let's say that's okay. Okay, so now we have the boxes there. Let's add the collider. This.physics.add.collider. So we're going to collide between the player and the box group. Okay, so it can't move past it. Okay. That's good. You can always adjust these box sizes to your liking in your game. Okay, now we should do some depth sorting here. What are we at on time? 10 minutes. So let's do a depth sort. So Phaser will actually do the depth sort for you. If you use the set depth method on each sprite, Phaser will then sort them by their depth that you give them, as long as they're on the same parent. So all of our game objects currently are on the scene. There's no containers, not inside containers, any of that right now. And so just giving them that number, you will see it sorted correctly. So now we're going to sort it by their Y value. And by doing that, we should get it pretty close to being right. So let's put here's the update. This is the bottom of the update. We are going to, let's see, look at all our children. Let's say that. How about that? So this not children dot each, and then for each child. So now let's see. Child is a game object, but really it's a arcade sprite. So we're going to do C. Do this similar trick that we just did before, and we're going to type this as what we know it to be. Phaser.physics.arcade.sprite. Now you will probably still get an error if you're using Visual VS Code, Visual Studio Code. Let's see, game object is missing the following property. This is a TS for TypeScript. VS Code is doing that, so we actually we don't care. So we do TS ignore to ignore all the TypeScript errors. Now the one valid error is from ESLint. And we'll end this child's declared but not used, so no one used var. So we will use this, so that doesn't matter. So child.setDepth, nope, not debug, depth. And we're going to use the child's Y position. Right, good. Now you don't necessarily have to do it in the update. You can do it only every time the player moves, is because no one else is moving, only the player is moving. So naturally, no one else's depth is being changed. You can do the depth, set the depth one time, and then call this again each time the player moves, or make like a dirty flag or anything like that. Keep it simple. We're just going to do it every update. There we go, and there he is. Right, look at that. It looks like we have depth. This is a 2D game, but they were adding some like 3D feeling to it by having some depth like this, like he's walking around the boxes as if we're in a more 3D-ish space than a 2D-ish space. So good, so now we have our player, we have the boxes. So next up what we're gonna do is know that when we're near a box, touching the box basically, it'll be allow us to select it by hitting the space bar. So we're gonna do that in part 3.